Hello, welcome to my video on partitioning clustering tables in big data. Partitioning and clustering. This is a fundamental concept in modern data warehousing and analytics, and it's crucial for managing performance and costs. For understanding, let's break down why we need to partition and cluster tables with simple analogy like library, and then dive into technical details and use cases. For example, a normal table. In library, consider that all books are thrown into a giant room or maybe hall with no particular order. For example, if we want to find all history books written in 18th century, then we have to enter into the room and look at the cover of each and every book to find the one we need. So in this case, we are scanning all the books. This is a slow process and inefficient as well. If I explain in the partition table concept, the library is now organized into separate rooms, one for each subject. Example: history room, science room, fiction room, etc. If we want history books, we only need to go to history room. We don't need to go to science or fiction room, and we will completely ignore other rooms. This will save massive amount of time, and this is called partitioning. Now, clustering the table. Let us consider inside the history room, the books are now sorted in shelves by the year they were written. Okay, if I want to find a book that was written in 18th century, I will directly walk into the history room, and in that room I will walk to the section of shelves which will have 18th century one, and I will not look into 15th century which is before 18th century or 21st century after 18th century. So this is called clustering. So partitioning means pruning the data. Partitioning physically divides large tables into smaller one, more manageable segments. For example, partitions based on the values in a specific column. And how does it work? When we run a query that filters an partitioning column, the database engine performs an action called partitioning pruning. It knows exactly which partition contains the date we are looking and scan only those partitions, completely ignores the rest. And the question comes, why we need it? The first one is performance improvement and cost reduction. Of course, this is the primary reason. By scanning less data, queries run significantly faster. In cloud data warehouse like BigQuery or anything, we often build for the amount of data scanned. So scanning the less data directly transfer to lower cost. And it's easier data management as well. It simplifies tasks like deleting old data. For example, if data is partitioned by month, and you can drop the entire month partition in single fast operation instead of running a costly delete statement on millions of rows. So likewise, it will save our bills. Now I'm going to show you a lab session uh, with a table with the tables which are created with partition, without partition. I will run similar query. There we can see the difference. How much it time take if the table is partitioned and if the table is not. So let me start by creating a schema first. Create a schema. I can give any name for now. I will give demo PC demo as with options. I'm use it in location US because next I'm going to create a table with a public data set which is available in US location, so I'm going to mention it in a US location first. So it is created here. Now it's turn to create a table. Let's do it quickly. Create or replace a table. I'm going to mention it in PC demo schema as base table. So I chose a table name as a base table. Why? Because I would like to distinguish that this is a table which is created without any technical partitioning. So here I will mention a class select star from BigQuery. This is the public dataset from the GCP, where this is the condition, because I'm not interested to dump all the rows of page views 2021 now. I'm gonna filter it only for October, where date hour greater than or equal to October 1st. Let me check my luck. So it is showing that this query will process 540.61 gigabytes when run. Okay, now it started. It will take a lot of time, 5 to 7 minutes. So I'm not going to keep you waiting for 5 to 7 minutes. So I will quickly pause for now and come back once the table is created. Okay, now base table is created. Let me check the details. Okay, details like these are the fields: data or wiki, title, and views. And if I check more details, oh my god, it has a lot of rows. And the query executed for 4 minutes 43 seconds. Okay, and 540 GB is processed, that I can see in the screen itself. Now I am ready with base table. So now I will run another query which will count the number of views to articles starting with letter Z for December. Okay, so let me run execute query. Select, we are interested in count of views. Okay, as used to pages from PC demo dot base table. Yeah, this is what we are interested. Perfect. Now we will mention this class. Where date hour. I said I want interested only for December, right? So give only for December 2021. And starts with letter Z. I'm running this query. We can see that this base table is not created with any techniques like partitioning, clustering. So in this case, it will run entire table and it will take some amount of time. Now it took 9 seconds with 476 gigabytes of data. So this is what we can make a note of it for now. This statistics will be useful for comparing with other tables that I'm going to create it. So now let me create a partition table. So fundamentally the partition table that is divided into segments called partitions. Thereby it makes easier to manage and query the data. So by dividing a large table into small portions, we can improve query performance and also cost. So this is the fundamentals of a partition table. But let me create a partition table first. Create this table. I don't know why always coming as table space. Okay, I will use the same schema for now. Wiki PC demo dot Now we will give it as a partition table just for our comparison. Okay, yeah. Partition by, how I am going to partition? With date. Yes. Now I will execute. I will copy. I think I can copy paste this base table query also. Here. Yeah. It's the same query. But here I'm using the technical partition. Let's run it. See how much time it will take. Query took 9 seconds. First I'm creating it now. Once the creation completes, I will execute query, similar query with, to view the views with letter G for December. This will also take some time. Definitely not as much as 4-bit something like that. But still, I will pause it for now, and I will come back once the table is created. Okay, now partition table is created. Let's see how much time it took. It took 1 minute 29 seconds. So the base table took 4 minutes, and with the partition technique it took only 1 minute 29 seconds. Now let's run a query. We will run the same query. We want to view articles with the letter Z. But from the partition table, not from the base table. I will copy paste this. Instead I will say I will mention partition table. Okay. So here used to pages, I should that's fine. I don't need to change it as of now. Let me check my luck. I need check the performance of the partition table query. Oh my, it's very fast. See, it took 1 second and only 153 gigabytes of data is processed. Whereas if I execute same query from base table, it took 9 seconds, 476 data is processed. And here only 153 GB process. So great improvement, huh? This is something we can clearly understand what is the advantage. Okay. So now, as I explained in the library analogy, these partitions were created in the table definition itself. So it will, when we execute for December, it will go to that table and retrieve. So it is very fast. Now let's execute something very different. For example, I would like to retrieve data which is not there in the base table. We know base table is created with only 2021 data. Let me query 2020. Of course, results will be 0, but let's see how does it work. Select count of views. Yes. Views to pages. Make a PC demo. That base table, right? Here date hour is less than or equal to 2020, 10 October 2020. Okay, title like. So we know that there is no data of this particular date range, but still base table is not created with any techniques like partition and clustering, right? So for sure it will scan the entire table, the rows, lots of rows. It will scan the entire rows and see 476 gigabytes were processed in 12 seconds, and the result is 0. It's a waste of our money. And now I will execute same thing with partition table. Okay, this query will process 0 bytes when run. Sorry, told me. Oh, this is so fast. See, because the beginning itself, it knows that there is no 2020. The bounce back and saying, boss, results are 0, 0 bytes process, and no 0, and the duration also is 0. So now we will go little ahead by creating cluster table. Okay, let me try that. Create or replace table. Wiki demo cluster table. I would like to give a name meaningful or sensible, so that by looking the name of a table we will understand whether this is partitioned or clustered. Now I will mention clustered by. This is a technique. Clustered by date hour as a title, as this is the query. So I can copy paste the query from here. Yeah, so I will paste it in the table that I'm gonna create cluster table. This will also take some time, definitely not like 4 minutes that was given in the base table. So when we create a cluster table in BigQuery in GCP, the table will automatically organize based on the contents of one or more columns in table schema. So the column we specify are used to co-locate related data. When we cluster a table using multiple columns, the order of we specify is very important. Here I mentioned date, hour, and title. Because this order of a specified column determines the sort order of a data. So sometimes we need to specify more than 2 for clustering. Okay, so in this query cluster by, we have mentioned date, hour, and title column. Now BigQuery sorts the data using these values in 2 columns. What happens when we submit a query that contains a class that filters data based on the clustering columns? Here is a date, hour, or title. BigQuery uses sorted blocks to eliminate scans of unnecessary data. So this is a advantage. Okay, table is created. Now let's execute similar query that we were executing it on base table and partition. I will copy it now. Same table. Instead of partition table, I will mention cluster table. Cluster table. Okay. So BigQuery is very smart. Upfront, it is mentioning how much data it is processing. Let's execute it and see how much time it will take. Wow, it's fast. 1 seconds, 103 gigabytes of data. No, not that one. So for partition table, 153 gigabytes, and for base table, it's 570, I guess. Let me check. 476 for base table. The same query for December with starts with G, it took 476, but for clustered, the same table, 103 gigabytes that were processed in 1 second. So we can see a lot of improvement in duration as well as bytes process. That's the advantage of cluster table. Ideally, we should cluster a partition table in real world. So let me first write a query, then we will discuss what is going to happen. Create or replace table. Oh my god, always it is going table space. It's okay. Wiki pc demo dot partition clustered table. Now I will mention partition by the same thing. Rate of date over. Now clustered by. Clustered by title as. Now that's the class. No, not this one. I should go back here, copy the same one, the same query. Let me manage alignment. Cluster by. It's not clustered, it's cluster by. So see, the execute details from past few queries shows that performance is better for the cluster table as well as partition table, which compared to base table. But performance will be even better if we create a clustering a partition table. Okay, now we will see that. So in this query, you can see on the screen, I have created a partition the table by date hour column and cluster by title column. So if table creates in WikiPC demo, then we will select this table and we can see how it has been created in the details. But for now we have to wait. So fundamentally we should use both the techniques if possible. I'm not saying somehow we have to use both partition clustering because it depends from the case to case, but yeah, that's best practice to do it both the cases. Yeah, it's less than 1 minute. No, 1 minute 9 seconds. So that is created. We will execute same query. Where is that? The table name is partitioned clustered table. Is it right? Partitioned clustered table. Yeah. Okay. Run it. Boom. Okay, it's 2020. No, I don't want to execute it. 2021, I think I should execute 2021. December. Yeah, December data. Sorry for that. So it took 1 second and just 12 GB data was processed. Why it is like that? Let's go through this table. See the details now. If we scroll down here, we can see information. It was clustered by title and partitioned by day, on day hour field. So that's why if I execute query on that particular date range, it safely picked up from the that location and shown the result. So we can see, right? It's much better. So finally, the conclusion, I would like to say that partition and or cluster tables will get best performance and lower costs. And we can even notice that BigQuery, it's smart enough to not process any bytes when it know that where condition would not yield any results based on the partitioning column, thereby avoiding unnecessary costs. So good luck for your practice, or good luck for your work. Use these techniques to save your time, save the bills, and also performance, for better performance. So here are the stats again. For base table creation, it took 4 minutes 43 seconds. But if we mention partition, it's 1 minute 16 seconds, and for cluster it's 1 minute 19 seconds. If we mention both, it's 1 minute 9 seconds. But if we query from base table for title with letter G for 2021 December data, it took 9 seconds. When it comes for partition, it's 1 second with 153 GB bytes processing. For clustering, it's 103 bytes processing. And for a table which is both partition clustered, it took only 1 second with 12.74 GB. So we can see the performance improvement here. If a table is partitioned as well clustered, so we can compare with base table. We can see a lot of improvement here. And the most important thing is, if we are querying something which doesn't exist in the table, if we don't partition cluster, it will scan the entire table and it will give us a bill with 0 results. Whereas if the table is clustered, it will give 0 results with 0 bytes processed. So that's how we can save the cost. So it's time for data engineers to prove their ability to mention partitioning and clustering tables to save the bills, cost, and also improve the performance. Good luck, guys.